Okay, all of this chapter ends up with the most important part, why we've been actually covering all this, and that it finishes with solving trigonometric equations. So first off, in this section, it says graph the function f of x equals sine x below. So let's go ahead and do that. And there you see a picture of your sine curve. Now, just a quick reminder, remember that sine curves are periodic or repeating functions. They repeat if you notice here, starts at 0, goes to 2 pi. They repeat every 360 degrees or 2 pi radians. And you have the exact same thing happening again. That is called the period of the function. That's going to be super, super important to us. The first problem over here says, give the solutions to the equation sine of x equals 1/2. So this is sine of x, and let's point out everywhere this sine of x is equal to 1/2. It's equal to 1/2 here, and it's equal to 1/2 here. Now be careful because here and here, it's actually equal to negative 1/2. So those two are not values. So where does the sine equal 1/2? At this x value and at this x value. And we can think about that. Okay, now that would be a 30 degrees or pi over 6. And then it occurs again over here in the second quadrant. Now, when I say second quadrant, the second unit circle quadrant, the same angle or the same reference angle, it would occur at 5 pi over 6. So those solutions occur again at pi over 6 and at 5 pi over 6. Now, give the solution on this interval. What if we're talking about the infinite interval? Okay, these solutions, if you remember correctly, again, it's periodic. This solution is going to occur again 2 pi units down the road. This solution is going to occur again 2 pi units down the road. So here's how we write this. The infinite solutions, pi over 6 is one of the solutions, but that solution is going to occur again 2 pi units. So we write it as pi over 6 plus 2, and we can put it as 2n pi, to where n is an integer. So think of it as 1 2 pi's, 2 2 pi's, 3 2 pi's, every 2 pi units. Okay, if you plug in a 1, you plug in a 2, plug in a 3. This 2 pi is a rotation. So this is going to occur again every 1 rotation, after 2 rotations, and this 5 pi over 6 as well. So 5 pi over 6 plus 2n pi's as well, to where n can be any integer. Now n can also be negative integers. So you can plug in like a negative 2 here, and that would mean this occurs after a negative 4 pi, which would be 2 rotations in the negative direction. Or you could plug in a negative 3, and that'd be 3 rotations in the negative direction. But this right here is simply how we tack on the infinite answers, all those other answers. So we need to write down here somewhere where n is an integer. I'm going to put n as an element of the z's, which means n is an element of the integers, or n is an integer. A trig equation can have one solution, no solutions, or several solutions depending on the defined interval. To solve a trig equation, here's the key. To solve a trig equation, we isolate the trigonometric functions. The cosine, the tangent, we get them by themselves. Okay, so number 1, solve by isolating. Solve for all variables on this given interval. So from negative infinity to positive infinity, we want all the answers. Okay, first off, let's get the cosines together. So I'm going to move it over by subtracting. You have 5 cosines minus 3 cosines leaves you with 2 cosine x plus root 2 is equal to 0. Now let's isolate our cosine x by first moving the root 2 over. So you have 2 cosine x equals negative root 2. Finally, divide by this 2, and you have now cosine of x equals negative root 2 over 2. Now here's the rule. Now find every solution within one period of this cosine function. Again, the period, if you remember, the period for cosine is every 360 degrees, or in this case, let's see, it says it doesn't tell whether to give it in degrees or radians, so you could do it either way. Since our example was in radians, then we'll give this in radians. Okay, where between one complete period from 0 to 360 or from 0 to 2 pi, where does cosine equal negative root 2 over 2? Okay, first off, where is cosine negative? All students take calculus. All students take calculus. Cosine is negative in the second and the third quadrants. So you're going to have an answer here, and you're going to have an answer here in one complete period. So let's see, where's cosine equal to? Well, I like to find my reference angle first. Where's cosine equal to root 2 over 2? Now let's do it in a different color. Cosine is equal to the square root of 2 at 45 degrees. So I'm looking for this angle and this angle, which also has a reference of 45. And again, notice I like using those degree measures just because right now I'm more comfortable. So let's do this angle will be 180 minus 45, which is 135 degrees. The other angle will be 180 plus 45, which is 225 degrees. Now in radian measures, those x values where we're equal to negative root 2 over 2, 135 would be 3 pi over 4, and 225 would be 5 pi over 4s. However, we want all the solutions. We want all the solutions from negative, positive, infinity. So we're going to tack on plus 2n pi and plus 2n pi to where n is an element of the integers. So these two answers plus any rotation or any repeated periods after those solutions. Now, what if, let's go back to these degree answers up here. What if you leave your answer in degrees? You're not going to do the plus 2n pi and the all that like you did down at the bottom. We're going to write it a little bit different. If you want your answer in degrees, instead of plus n times a rotation of 2 pi, you will do 360 times n. Because instead of 2 pi, you have 360 degrees as a rotation. So that would be your degree answer, and you see the radian answers down below. Okay, number 2. Again, let's isolate. Let's move all of our tangents to one side. So I'm going to mark this out and add 3. I now have 6 tan theta. Let's go ahead and take this 2 root 3 and subtract it from the other side, and you have 6 root 3. Get rid of the 6 by dividing, and you have the tangent of theta is equal to root 3. We want all the answers between negative infinity and positive infinity. Now remember tangent. Tangent has a period. I'm going to write it over here. The period of tangent is just pi or 180, not 360. So what I'm going to now look for is all answers in one period from 0 to 180. Now, where is tangent equal to a positive root 3? That would be in the first quadrant because, again, all students take calculus. Everything's positive here. What is the value that gives me a tangent that's equal to root 3 would be a 60-degree angle. But if you want that in radians, 60 degrees we know is pi divided by 3. Be careful. This answer will occur every pi units. Again, the period for pi is not 360 or 2 pi, or the period for tangent. The period for tangent is pi units, so this answer will occur again every pi times n units, where n, again, is an element of the integers. So pi over 3 plus 1 pi would be another answer. Pi over 3 plus 2 pi's is another answer. Plug in any integer here, and it's going to give you more answers or more solutions to this equation. Okay, number 3. Again, let's isolate our cosecant. Let's get rid of 4 by multiplying first. So we have the cosecant of alpha minus 6 is equal to negative 4. Let's get rid of minus 6 by adding 6. So we have the cosecant of alpha is equal to 2. Now be careful, this minus 6 is not inside with that alpha. The alpha is the angle, okay? The minus 6, that's the reason I was able to move the minus 6 over. Now, I'm not comfortable with cosecant, so what do? Use your reciprocal identities. If the cosecant is 2, then that means the sine, which is the reciprocal, would be 1/2. So let's turn it into a sine, cosine, or a tangent, and let's solve it. Okay, draw your quadrants. We're looking for where sine is positive. Sine is positive in the first and the second quadrants. So we're going to have an answer here, and we're going to have an answer here. Start by finding your reference angle. The sine of 30 is 1/2. So therefore, we're going to have another answer over here that has the same reference angle. So therefore, alpha will equal 30 degrees if it's in the first quadrant, and alpha will equal, that would be 150 in the second quadrant. Change each of those to radians. 30 would be pi over 6. And so therefore, this is 5/30s here, so that'd be 5 pi over 6. So there's your two radian answers. And again, to find those infinite values, those answers are going to occur every 2n pi units. So plus 2n pi. There's all your solutions. Next up, number 4. Isolate your secant. So let's move this 1 over. We now have 6 times the secant of y is equal to negative 4 root 3. Divide by 6. And let's reduce that. That means that, scroll back up, the secant of y is equal to negative 4 over 6 will reduce to 2 root 3 over 3. But again, we're not comfortable with secant. So what do? We change it to cosine. So the cosine of y would equal the reciprocal of that, which would be negative 3 over 2 root 3. Let's rationalize by multiplying top and bottom by root 3. So it means that the cosine of y has to equal, let's see, that'd be negative 3 root 3. You can do this. Root 3 times root 3 is 3, so you can cancel that with that. And that leaves you with negative root 3 over 2. Okay, now where is cosine negative? Let's draw our unit circle quadrant here. Cosine is negative in the second and in the third quadrants. Find your reference angle. The cosine of what is root 3 over 2? That'd be in the first quadrant. The cosine of what angle is root 3 over 2 would be a 30-degree angle. So therefore, your answers are going to be here and here, and they're going to have reference angles of 30 degrees. So that would mean that y is equal to 150 would be this angle, which has a reference of reference of 30, or y is equal to 210, which would be 180 plus an additional 30. There's your two angles. Since they do have a reference angle of 30, 30 is pi over 6, so this one would be 5 of those, 5 pi over 6. And this would be 7 30s, so that would be 7 pi over 6. And those answers, again, occur so plus 2n pi units, plus 2n pi units. So there are your infinite solutions, actually. Okay, next one, a little bit different. On this one, we're only going to look for the answers between 0 and 2 pi. So that's only the answers in one complete rotation. So let's isolate our tangent, get them both together, subtract. You have 2 tan A is equal to negative 2. Divide by 2, and you get the tangent of A is equal to negative 1. So let's find all the answers between 0 and 2 pi. That's one complete rotation, not one complete period, because the period of tangent would just be 0 to pi. So they're wanting in a complete rotation on this one. So what are the answers to tangent of A is equal to negative 1 between 0 and 2 pi? There are going to be two answers. All students take calculus. Tangent is going to be negative in the second quadrant, and tangent is negative in the fourth quadrant. Again, first step, I like to find my reference angle. Where is tangent equal to 1 would be at 45 degrees. So I'm going to have an answer here that has the same reference. I'm going to have an answer here that has the same reference angle. So if this is 45, we're going to do 180 minus 45, which is a 135-degree angle. And this would be, this is 45 as well, so we're going to do 360 minus 45, which is a 315-degree angle. Our reference angle is pi over 4, 45, which is pi over 4. So this would be, you can take, there's going to be 3 45s and 135, so let's change that now. That would be 3 pi over 4s, if you write it as a radian. 3 pi over 4. And 315 would be 7 pi over 4. So that's all of your answers. On this one, we're only finding answers from 0 to 2 pi, and that would be all of them. Next one, we're finding all the answers between pi and 3 pi over 2, which is all the answers between 180 and 270. So let's first isolate the sine squared. Move the 8 over, it gives you 4. Sine squared u is equal to 3. Let's get rid of the 4 by dividing. And let's get rid of the square by taking the square root. Be careful, because we have to do plus and minus the square root of 3/4. And that's going to be the square root of 3/4. That's going to be the sine of u is equal to positive and negative square root of 3 over 2. I square rooted the top and I square rooted the bottom. So therefore, all the answers between pi and 3 pi over 2, which would be all the answers from 180 to 270. All the answers from here to here where sine is either positive or negative root 3 over 2. Let's find a reference angle. Your first quadrant angle where sine is equal to root 3 over 2. That's a 60-degree angle. So we're looking for a third quadrant angle. Again, this is third quadrant. Looking for a third quadrant angle that has the exact same 60-degree reference. So we'll do 180 plus 60. That is a 240-degree angle. That's the only answer. However, we want it in radians. So 60 was my reference, which would be pi over 3. This would be 4 60s, so that would be 4 pi over 3. That is the only solution between pi and 3 pi over 2. Number 7. We're looking for all solutions between 0 and 2 pi. Now this you're going to have to solve by using factoring. I don't think we're going to have to factor this one, but we can. Let's go ahead and show you how to solve this by factoring. Same way that we have been. Perfect square, difference. This is difference of squares. Difference of squares factors into conjugates, plus and minus. What multiplies give you 4 cosine squared to be 2 cosine and itself. Multiplies give you 1 to be a positive 1 and a negative 1. Set each factor equal to 0. So you have 2 cosine x plus 1 is equal to 0, or 2 cosine x minus 1 is equal to 0. Solve each of them. You get the cosine of x is equal to negative 1/2, and the cosine of x is equal to positive 1/2. So we've got each of them solved. We're looking for all the answers between 0 and 2 pi. So let's draw our unit circle axes there. So anywhere the cosine is negative 1/2 or anywhere the cosine is positive 1/2, let's find our reference angle. Cosine is equal to 1/2 at 60 degrees. Cosine, now where is it positive or negative? That would be every quadrant now. You're going to have an answer here, you're going to have an answer here, and you're going to have an answer here. Between 0 and 2 pi, you're going to have 4 different answers. And those answers are going to be 60 in the first quadrant, 120 has a reference angle of 60 in the second, 240 has a reference of 60 in the third, and 300 has a reference of 60 in the fourth. Now 60 is equal to pi over 3. Okay, so my answers are going to be x is equal to pi over 3 in the first quadrant. This is 2 pi over 3s, or 2 60s, so 2 pi over 3 in the second quadrant. This is 4 60s, so 4 pi over 3 in the third quadrant. And this is 5 60s, so 5 pi over 3 in the fourth quadrant. Okay, the next one, let's work number 8. Now, again, we're solving these by factoring. Notice you have a cotangent mixed with the sine stuff, and we don't like that. We could try to simplify it, but there is a way to separate it. We can't mix functions in order to solve these. So what I'm going to do, move everything to the same side. So I have cotangent of x minus the cotangent of x times sine squared x is equal to 0. Let me erase that. There we go. Next step, you have 2 terms. Both of those terms contain a cotangent of x. So let's factor out a cotangent of x. You're left with 1 minus sine squared. And notice what we have done. We were able to separate the cotangent from the sine stuff. So now we can set each of those equal to 0, just like if it were a quadratic equation. Cotangent of x is equal to 0. 1 minus sine squared x is equal to 0. Now, if you wanted to, you could actually factor that again. You could do difference of squares right here and do 1 plus sign and 1 minus sign. If it's a perfect square there to where I can isolate that square, most of the time I'll just leave it like that. Now again, I don't like working with cotangent. I like working with tangent. So you're looking for where the cotangent of x is equal to 0 or 0 over 1. That means where is the tangent equal to 1 over 0? Now that's odd. That is undefined. So we're pretty much looking for where is tangent undefined. And that's going to be where cotangent is equal to 0. Now between pi and 2 pi, so we're looking for all answers from 180 to 360. Where is tangent undefined? Where's my slope undefined? And that x value is going to be at 270 degrees. That'd be 390s, so that'd be at 3 pi over 2. That's 270 degrees. There's my first solution. Okay, next solutions. Let's come over here. Let's move our sine squared over, and I get 1 equals positive sine squared x. Now again, you could have solved this by factoring, but I like to do it like this. To get rid of a square, let's square root. Don't forget to do plus and minus. So you get where is sine of x equal to positive 1 or negative 1. So therefore, and we're only looking for answers between pi and 2 pi, where is sine equal to positive 1 or where is sine equal to negative 1? Now remember your unit circle. Sine is the y value on your unit circle, and where is sine equal to 1 would be, or actually negative 1 would be right there at the exact same 270. So you have only one solution here. Both of them are true at 3 pi over 2. So your answer to this equation would be just 3 pi over 2. Okay, number 9. Again, we're looking for all the answers between pi and 3 pi over 2. That would be all the answers in the third quadrant. 3 tan squared. Now here again, notice that you have two terms. Both terms contain a tan u. So let's factor out the tan u. You're left with 3 tan u minus root 3 is equal to 0. Now that you have a factor, set each factor equal to 0. The tangent of u is equal to 0, or 3 tan u minus root 3 is equal to 0. Isolate or solve for 0. In the second one, let's move this term over and divide by 3. And it gives you the tangent of u equals, when you move the negative square root of 3 over, you have now the positive square root of 3. Divide that by the 3 here. So you have where is the tangent of u equal to 0? And where's the tangent u equal to root 3 over 3? But again, we're only interested in this third quadrant. So let me draw that. Only interested, and it is inclusive. We're interested in everything between pi, which is 180 degrees, and 3 pi over 2, which is 270 degrees. The tangent of u on our unit circle, where's the tangent of u equal to 0? That's going to be at 180 degrees, or pi. Where are we equal to root 3 over 3? Let's look at our reference angle up here. Root 3 over 3 would be a 30-degree angle. So the 30-degree angle beyond the 180 here would be a 210-degree angle. That's going to be my other solution. So my other u, okay, 30 degrees here is pi over 6. So that's my reference. 210 will be 7 of those, so it would be 7 pi over 6. That's my two solutions. Okay, the next one, number 10. Looks like we have three terms here. All three terms contain a sign, so we can combine any like terms that we do have. These can be combined because of the 2 and the 2 root 2. So let's move it over. So you have the sine of x times the secant of x, plus when you subtract this root 2, that's 1 root 2, subtract from the 2 root 2, and you're left with a 1 root 2 sine x is equal to nothing. Factor your sine x out of each term. So you have sine x times the secant of x plus the square root of 2 is equal to 0. Let's set each term equal, or set each factor equal to 0. So sine x equals 0, or the secant of x plus root 2 is equal to 0. Move that root 2 over to isolate your trig function, and you get secant of x is negative root 2. However, again, you're not as comfortable with secant, cosecant, and cotangent as you are with sine, cosine, and tangent. So let's change our secant x to a cosine of x by finding the reciprocal. So 1 over root 2, or let's rationalize that. That'll be root 2 over 2 when you do. So where we are dealing with between 0 and pi, so let's kind of sketch that out. Where between 0 and pi, or 0 and 180, is the sine of x equal to 0. Reminder that if you're thinking about unit circle, let me kind of sketch just a half unit circle. Where is my y value between 0 and 180 on my unit circle? Where is my y value 0? And there's two different spots. And those two spots are at 0 degrees and at 180 or pi radians. There's two of your answers. The next question is, where is cosine equal to negative root 2 over 2? Well, let's start with our, first off, let's start with our reference angle. Whereas cosine equal to root 2 over 2 is at a 45-degree angle. However, a negative root 2 over 2, cosine is negative in the second quadrant. So you're going to have that same reference angle here as you did over here. It's a 45-degree reference angle. Subtract that from 180, that's a 135-degree angle. So therefore, your other answer, whereas cosine equal to negative root 2 over 2, well, it's going to be a multiple of that 45. And you can divide it out if you need to, but there are 3 45s and 135. So your second angle is going to be 3 pi over 4. Number 11. We're looking for 3 pi over 2 to 2 pi. That's the fourth quadrant answers for this equation. Let's move our cosecant x over. We'll move our 7 over, and it gives you cosecant squared theta plus the cosecant of theta. When you move the minus over, when you subtract 7, it gives you minus 2 is equal to 0. Now what you have here is a quadratic trinomial. So you're going to factor it just like it was x squared plus x minus 2. You're going to say what adds to give me this, multiplies to give me this. So two sets of parentheses. Cosecant times itself. Just like normally it would be x times itself. Adds, multiplies would be a positive 2 and a negative 1. Set each factor equal to 0. Cosecant theta plus 2 is equal to 0. Cosecant theta minus 1 is equal to 0. Move your constants over so you get the cosecant of theta is negative 2 and the cosecant of theta is positive 1. Again, we're not comfortable working with cosecant, so let's change them both to sines. The sine of theta is the reciprocal of negative 2 over 1, which would be negative 1/2, or the sine of theta is equal to 1 over 1. So now we're asking ourselves, in the fourth quadrant, let me kind of draw a picture here. In this fourth quadrant over here, where on our unit circle do we have a sine value? Let's start with, where do I have a sine value of negative 1/2? Well, I need a reference angle. Up here in the first quadrant, what is my angle where sine is positive 1/2? And that is a 30-degree angle. So in my fourth quadrant, I could do a negative 30 degrees, or I could say if this is my reference angle of 30 degrees, what is my actual angle? If this is 30, then this part right here would be 360 minus that, which would be 330. So my reference there was pi over 6. And again, I know this is a multiple of it. There is 11 30s and 330s, so that would be 11 pi over 6. That's my first answer. My second answer is where between, let me erase those, where between 270 and 360 do I have a sine value of 1? And on my unit circle, the sine values is a y value. This is where I have a sine value of 1 at 90 degrees. However, if I come down here and use that reference angle, that would be a sine value of negative 1. So there's no solutions to this one. So your only answer is going to be 11 pi over 6. Okay, number 12. Again, it's a quadratic trinomial. However, there's a number out front. This is a bottoms-up factoring. So what you can do, let me show you this. If you don't want to keep writing the sine squared over and over and over, you can do a u substitution and write it like this, factor it, and then put the sign back in. So I took out the signs and I replaced them with just a variable. It doesn't matter which one. Now let's go ahead and factor this. Move the 2 to the end. Slip and slide factoring. So that'd be minus 4 equals 0. Two sets of parentheses. You have u times itself. adds multiplies is a positive 4 and a negative 1. Set each factor equal to 0. So u plus 4 equals 0. U minus 1 equals 0. Now, what is u? Well, we haven't, hang on, messed up. This was slip and slide. So since I moved the 2 to the end, we now divide by the 2. I treated it like regular factoring there for a second. So that would be u plus 2. And since this does not reduce or divide, move the 2 back up front. That'd be 2u minus 1. Now set each factor equal to 0. So you have u plus 2 is equal to 0, or 2u minus 1 is equal to 0. Now go back. What is u? U is sine of alpha. So you could actually take out these u's and replace them back with the sine of alpha. So there we go. Isolate each, so you have the sine of alpha, move the 2 over, is negative 2. Move the 1 and the 2 over, and that give you the sine of alpha equals 1/2. Now, if you remember psi, and you can remember this from the unit circle, you can remember this from your tables and all this, or your graphs even. Sine has a range between -1 and +1. Before I even try to work this out, I already know it has no solution. There's absolutely no way that sine can be -2. It's outside of its range. However, where does sine equal to 1/2? Everywhere between 0 and 2 pi is what we're looking for. So one complete rotation, we're looking for where does sine equal to 1/2. Well, let's find the reference angle to begin with. And that reference angle where sine is equal to 1/2 is 30 degrees. Now, where else is sine positive? All students take calculus. Sine is positive here and here. So I'm going to have another answer over here that has that same reference angle. Take 180, take 30 away from it, that'd be a 150 degree reference angle. Or 150 degree angle, excuse me. So therefore, my other two answers for alpha was the 30 degrees, which is pi over 6. And another angle here that had a reference of 30, and there are 5 30s and 150, so there'd be 5 pi over 6. There's your two solutions. Number 13. All the answers between pi and 2 pi, that'd be all the answers between 180 and 360. For this, let's combine all of our like terms. When you move the secant squared over here, excuse me, we're going to subtract. So I now have the secant of the fourth, secant to the fourth power x, minus 5 secant squared x. Move the minus 1 by adding 1, that'd be plus 4 is equal to 0. We're going to do regular quadratic factoring, and you can use a u substitution here if you'd like to, but I've got secant squared x times secant squared x. That's just like it would be like u squared times u squared is u to the fourth. Adds, multiplies is a -4 and a -1. Set each factor. Well, actually, let's factor again. You can do difference of squares here. Well, you can. And turn that into secant x minus 2 and secant x plus 2. It factors into conjugates. But we know once we hit quadratic, we can actually use those other methods. We can just isolate this by taking a square root, and it's actually going to be a little bit easier. So secant squared x minus 1. Set them each equal to 0. Move the 4 over. I'm going to go ahead and do this one. Move the 1 over. Do plus and minus the square root. So secant x will be plus and minus the square root of 4, which is 2. Or secant x will be plus and minus the square root of 1, which is 1. We're not comfortable with secant, so let's deal with cosine. So if the secant of x is positive -2, then the cosine will be positive -1/2, or the cosine of x will be positive and -1. So that's what we're looking for. Where between pi and 2 pi, which is here, where between pi and 2 pi do I have a cosine value of positive or -1/2? So what that says is you don't have to worry about the sign. You don't have to worry about what quadrant you're in because you're dealing with all the positives and all the negatives. So my reference angle to begin with, though, is up here. My reference angle for where sine is equal to 1/2 is 60 degrees. So you're going to have an answer here and here with that exact same reference. This will be 180 plus 60, which will be 240 degrees, is my one answer here. This will be 360 minus 60, which is a 300-degree answer. So there's your two answers. Your reference angle is 60, which is pi over 3. These should be multiples of 60. There's 4 60s in that, so that'd be 4 pi over 3. This is 5 60s, 300, so that'd be 5 pi over 3s. So there's those two answers. Now the next one's where is my cosine equal to positive or negative 1? Reminder that a cosine value is an x value on your unit circle. So for which x value do I have, or for what angle do I have an x value of positive 1 or an x value of negative 1? Well, that'd be on my unit circle right here and right here. This is the point negative 1, 0. This is the point positive 1, 0. So my other two answers would be 180 degrees here, or pi radians. And then 2 pi radians over here would be my last answer. So there's all 4 of the answers to that equation. Okay, the next one, number 14. Again, looks like we have 4 terms here actually. So a factoring problem, and we're just reminding ourselves of all those factoring methods we went through. This is factoring by grouping. So my first group, I'm factoring out, and you can use substitutions if you'd like to. We don't have to. I'm going to factor out a tan squared y. Out of my first group, you're going to left with a tan y plus 1. Factor out a negative 3 out of my second group, and you're going to be left with a tan y plus 1. Since both groups are the same, let's factor the tan y plus 1 out of both groups. You're going to be left with a tan squared y and a minus 3. There you go. Since you are down to quadratic, set each of those factors equal to 0. So the tan y plus 1 is either equal to 0 or tan squared y minus 3 is equal to 0. So either the tangent of y is equal to negative 1 or tan squared y is equal to 3. So therefore, the tangent will equal positive or negative square root of 3. So there's what we're looking for. Where is tangent equal to negative 1 or positive or negative root 3? Between 0 and pi. So let me draw those solutions out here. So we're looking for all answers from here to here. Where is tangent equal to negative 1? Now my reference angle, let's begin with that. Where is tangent equal to positive 1 would be at 45 degrees. So I'm going to have an answer over here where all students take calculus. So sine is the only thing positive. So tangent will be negative right here. It's going to have the same reference angle of 45. So that would be take 180, take 45 away from it. That's 135 degrees. That's going to be, okay, 45 would be pi over 4. So it should be a multiple of pi over 4. That's going to be 45, 90, 135. That'd be 3 pi over 4s. There's your first answer. Now the next one, where is tangent equal to root 3 or negative root 3? Let me erase those angles. Tangent is equal to root 3 at 60 degrees, which that will be a solution because that's where it's equal to positive root 3. You're going to have an angle in the second quadrant that is also a 60-degree reference, just like the first one. That'd be a 120-degree angle, which would be, let's see, that'd be 260, so 2 pi over 3s. So there is all your solutions. Number 15. Now here it says solving using basic identities. Now what we mean by that is when we're solving these, if you can't isolate just the cosine or just the sine by itself, sometimes it's best to change sines into cosines or change cosines into sines to where everything that we have in a problem is all the same trig identity. Trig function. So here I have cosines and sines. Well, is there any way that I can change either one of these to the others? And there is. Since this is sine squared, reminder, let's scroll all the way back up to the top. It's one of our very first identities. We can change sine squares into cosine squares by using this Pythagorean identity. So I know sine squared is cosine plus cosine squared is 1. So I know that, let's say we're wanting to change cosine or sine squared into cosine squared. So if we were to move this over, I get sine squared is 1 minus cosine squared. So let's take out that sine squared and let's replace it with 1 minus cosine squared. And now we have everything is cosine stuff. It's quadratic now, so let's move everything to the same side. Move this minus cosine squared over, and it gives you positive cosine squared. We already had a positive cosine over there. Move the 1 over, and it becomes minus 1, so you have minus 2 equals 0. And now it's just like the problems we worked before. Two sets of parentheses. Cosine x times itself gives me cosine squared x. Adds to give me 1, multiplies to give me negative 2 would be a positive 2 and a negative 1. Set each equal to 0. Cosine x plus 2 is equal to 0, or you can go ahead and move that over, so that'd be cosine x is negative 2. And the second one would be cosine x minus 1 equals 0. Move the minus 1 over by adding 1. So there's your two setups. So where does cosine equal to negative 2? Nowhere. That's outside of the range. However, on my unit circle, where does cosine equal 1? And we're finding all answers between negative and positive infinity. So we're finding every solution here. So on my unit circle, let me kind of sketch out a small circle here. On my unit circle, a cosine value is an x value on my unit circle. There's only one place where my x value is equal to 1, and that's right here at 1, 0. So therefore, that would be a 0-degree angle or 0 radians. However, that same answer occurs, the period of cosine is 360 or 2 pi. So that same answer occurs every 2 pi units. So we're going to tack on that plus 2 pi in like we did before. So 0 is an answer, 2 pi is an answer, which I think they wrote it as 2n pi. You can do it either way. 0 is an answer, 2 pi is an answer, 4 pi is an answer, where n is an integer, so that's going to be all your solutions. So really the 0 doesn't matter. 0 plus something is just that. So 2n pi, all the 2n pi's are going to be your solutions there. Okay, number 16. We have cotangent squares mixed with cosecants. So is there any way to change cosecants to cotangents or cotangents to cosecants? Would be right here. So again, that's another Pythagorean. So cotangent squared would be, move the 1 over. We can replace cotangent squared with 1, or cosecant squared minus 1. So that's going to be cosecant squared minus 1 of theta. Minus 3 cosecant theta plus 3 is equal to 0. Let's combine all of our like terms. You have cosecant squared theta minus 3 cosecant theta. Combine the minus 1 and plus 3 gives you a plus 2 is equal to 0. And we're doing the exact same thing. Two sets of parentheses. Let's factor. Cosecant theta times itself gives me cosecant squared theta. Adds, multiplies is a negative 2 and a negative 1. Set each factor equal to 0, and I'm going to skip a step here. Set each of these equal to 0 and solve, and you're going to get the cosecant of theta is 2, and the cosecant of theta equals 1. Let's work with sine instead of cosecant, so the sine of theta would be 1/2, and the sine of theta will be 1. So we're looking for all answers in one rotation between 0 and 2 pi. So let's sketch that out. So one complete rotation, any answer is going to be fine. First off, where is sine equal to 1/2? You have a reference angle here of a 30-degree angle, and that's actually going to be one of the solutions because sine does equal positive 1/2 there. But you also have a second quadrant answer where sine is also the same value, the same y value, and that's going to be a 150-degree angle, which again should be also a multiple of pi over 6 since it is the same reference angle, and there is 5 30s and 150s. So there is your two answers to this one. Now the next one is, where is my sine value equal to 1? And again, if you remember your unit circle, that would be, where is my y value on my unit circle equal to 1? There's only one place, and that would be right there. Because down here, your y value would be negative 1. That's a quadrantal angle. Here your y value is 0, here your y value is 0. So that's going to be, theta would be a 90-degree angle or pi over 2. So there's your three solutions. Number 17. Now you have tangent stuff mixed with sine stuff. So what we can do is let's change tangent to sine over cosine. And what we're going to be able to do, since there's a sine value here, we're going to be able to factor all those sine values out and kind of isolate them completely. So let's factor sine out of each term. So you have now the sine of alpha times 3, and that would leave you with 1 over cosine whenever you factor it out of that. And I don't want to leave it as 1 over cosine. 1 over cosine would be secant. So you're left with 3 secant alpha minus 2 root 3 is equal to 0. So let's set each equal to 0. The sign of alpha is 0. The second term, 3 secant alpha minus 2 root 3 is equal to 0. Move the 2 root 3 and the 3 over, and that gives you the secant of alpha is 2 root 3 over 3. So therefore, the cosine would be 3 over 2 root 3. Let's rationalize that by multiplying top and bottom by root 3. The root 3 times root 3 would cancel with this, and it would leave you with a root 3 over 2. So there's our two things that we're going to solve now. Where is sine equal to 0, and where is cosine equal to root 3 over 2? Now we're looking for all the answers between pi and 2 pi. So that's all the answers between 180 and 360. Where does sine equal to 0? Again, sine is a y value. These 2 points on my unit circle, sine is equal to 0, and that would be at pi and at 2 pi. So there's 2 of my solutions. Where's cosine? First off, where's cosine positive? All students take calculus. This is the only quadrant we're going to have a positive cosine. Let's use this to find our reference angle. Where's cosine? First off, equal to root 3 over 2. That's a 30-degree angle. So you're going to have an angle right here in the quadrant that has the same reference angle. Take 30 from 360, that would be a 330-degree angle here. So my reference angle is pi over 6. 330 should be a multiple of that, and it is. There's 11 30s in 330, so therefore there's your other solution. Okay, number 18. Now this one's a little tricky. You could try to change secants and tangents to be the exact same. You're not going to have a lot of success with that because we could change secants to 1 over cosine, tangents to sine over cosine, and you're not going to be able to factor that out because, well, one main reason, this is not equal 0. It's not going to factor out like the other ones did. However, this one provides us with an opportunity to show you a trick that you can use. What I'm going to do first off is I'm going to separate these secants and tangents. I'm going to keep secant on one side, move that tangent to the other side. That'd be 1 plus tangent. Now, the relationship between secants and tangents, if you'll go back over here, it's right here. There's no relationship between just plain secants and plain tangents. There's a relationship between squared secants and squared tangents. So what you can do is actually take what you're left with and square both sides of it. And that's going to create some squared secants and squared tangents. So the square of secant here, that'd be secant squared x, like we need. When you square tangents, you do have to FOIL this out. I'm going to go ahead. I'm not going to go through all the steps of that, but I am just going to go ahead and FOIL. And here's what you'll be left. We're squaring this, so you're going to square this. You're going to multiply the 2 and double it. Then you're going to square the second one. And that's what you now have. And what you can now do, you have all tangent stuff on the right side. Well, since I have secant squared, I really have tangent stuff over here now because of that identity I was just saying. Secant squared is tan squared plus 1. So I can now take out this secant squared and I can replace it with tan squared x plus 1. So now I have all tangent stuff. So let's move all the stuff to the same side. When you move tan squared, they actually cancel each other out. That's nice. When you move the plus 1, they cancel each other out. So you're left with 2 tangent x, and that's it. Equals nothing. Divide by 2, and that's gone. So you're pretty much simply looking for where does the tangent of x equal 0. We're wanting all solutions from 0 to 2 pi. Our reference angle, where is tangent equal to 0? Tangent's equal to 0 at 0 radians. So it's also going to equal it over here. So therefore, my two solutions between 0 and 360 is going to be at x equals 0 and at x equals pi units. So that's our radian solutions. Okay, the next one. We have sine of pi over 6 minus beta minus cosine of pi over 3 minus beta equals root 6 over 2. Now this one is titled using sum and difference identities. So let's see if we can clean this up a little bit before. We can see the difference identity right here, the sign of something minus something. We can also see a difference identity here, so let's apply those. Now, a good reason, let me point this out, that we can apply these is notice that the pi over 6 and the pi over 3s, we can find the sines and cosines of those. So we could clean this up a good bit by using these. So sine of a minus b is right here. That's the first identity we're going to use. So every a and every b are going to be replaced with pi over 6 and beta. So I'm going to go ahead and plug all those values in. Now you have minus, and I'm going to put this in parentheses because it's minus the whole thing, the cosine of a minus b. So now let's apply this identity. And again, every a and every b is pi over 6 and beta. So let's go ahead and I'm going to use, again, that identity there to plug all those values in. There we go. And that's equal to root 6 over 2. Now, there's a lot of stuff here, again, that we can clean up. All of these, the pi over 6, by the way, is 30 degrees, so I'm going to replace all of those with their equivalent values. The sine of 30 is a half, so I now have 1/2 cosine beta minus root 3 over 2 sine beta minus, in parentheses, cosine of that was root 3 over 2 cosine beta. Plus 1/2 sine beta is equal to root 6 over 2. And I actually made a mistake. Let's go back and fix something. This was supposed to have been root 3 or pi over 3s instead of pi over 6s. So let's replace both of those with pi over 3s. And that's going to change. Those are 60-degree angles. So that's going to change this and this right here. The cosine of 60 is actually 1/2. The sine of 60 is root 3 over 2. There we go. So what we have now is when you distribute this negative sign, here's what's going to happen. You have a 1/2 cosine of beta here that's going to combine with and cancel out with this 1/2 cosine of beta. And you're going to have a negative root 3 over 2 minus root 3 over 2. And that's going to be negative 2 root 3 over 2 sine beta. And those 2's will reduce, is equal to root 6 over 2. That's all we're left with there. Let's multiply to get rid of this negative root 3. Let's multiply the other side by the reciprocal, which would be negative 1 over root 3. And that's now going to be gone. And that leaves you with the sine of beta is equal to root 6 and root 3 cancels and leaves you with root 2. So it'd be a negative root 2 over 2. So we're looking for all answers between 0 and 2 pi, where sine is equal to negative root 2 over 2. My reference angle is going to be a 45-degree reference angle. However, whereas sine negative is going to be in the third and the fourth quadrants down here. So I'm going to have an answer here, and I'm going to have an answer here. This is 45 degrees, this is 45 degrees, so this would be a 225-degree answer. This would be a 315-degree answer. So those two values here and here should be multiples of that 45. So my two answers are going to be multiples of pi over 4. 225 is going to be 5 pi over 4s. 315 is 7 pi over 4s. So there's your other two answers. Next up, exact same scenario. You have the cosine of an angle plus an angle and the cosine of an angle minus an angle. So let's go back to my identity sheet. And to do the cosine of an angle plus an angle, we're going to use this identity right here. So let's go ahead and plug all these values into that. And then you have plus the cosine of an angle minus an angle. So we are now going to apply this identity to that. So let's go ahead and plug all those in. And that's going to equal, let me scroll up a little bit, the square root of 2 over 2. Now, I can go ahead, I have 4 terms over here on this side now. And before I even simplify or evaluate anything, negative sine pi over 4 sine will cancel with positive sine over 4 sine. And that's going to leave you with these two terms, which will combine. This is going to be root 2 over 2 cosine x. And this will also be plus root 2 over 2 cosine x. And those will combine as equal to root 2 over 2. Now, I noticed something. All three of my terms, and I can do this to clean this up just a little bit. All three of my terms have a root 2 over 2. If you want to divide all three of those terms by root 2 over 2, that's actually going to make all this stuff equal to 1. So you have cosine x and cosine of x, which is 2 cosine x, is equal to 1. So that's one trick. You could have done it the other way and combined it, but then you're having to work with roots and all that. So divide each side by 2, and that gives you cosine of x as a half. We'll look for all answers in one rotation between 0 and 2 pi, where cosine is 1/2. My reference angle is going to be 60 degrees. And that is going to be one of the solutions because cosine is positive in the first quadrant and in the fourth quadrant. So you're going to have an answer in the first and the fourth. If this is 60, that's going to be a 300-degree angle. So your two answers are going to be pi over 3, which is 60, and some multiple of pi over 3. There is 5 60s and 300, so therefore that would be 5 pi over 3. There's your two solutions. Okay, number 21. Now here it says solve using double angle identities. Now why are we going to have to use double angle identities? Because we have a sine of 2u here. So we're going to change that and use that double angle identity. So we can replace, we know the sine of 2u, we can replace with 2 times the sine of u times the cosine of u, which is our double angle identity right here for the sine. So we have that plus 4 cosine u equals 3. So let's move this over, and that's going to be plus 1 cosine u, and that's going to equal 0 now. You have two terms. Both of them contain cosines, which can be factored out. So pull that cosine u out. You're left with 2 sine u plus 1 is equal to 0. Set each factor equal to 0, so that'd be either the cosine of u equals 0, or when you set this factor, I'm going to go ahead and skip a step, solve that when you set it equal to 0. That's going to be the sine of u is negative 1/2. We'll solve each of those. We'll look for all solutions between 0 and 2 pi. So first off, where does cosine between 0 and 2 pi, where is cosine equal to 0? Again, cosine is an x value. So on your unit circle, where is x equal to 0? That'd be right here and right here. Those are quadrantal angles. That's going to be 90 degrees, or pi over 2. And this would be 270, which is 3 pi over 2s. So there's two of your answers. Now next up, where is sine equal to negative 1/2? Reference angle there would be a 30-degree angle. However, sine is negative here and here in the third and fourth quadrants. If this is 30, then that'd be a 210-degree angle. If this is 360, or this is 30, 360 minus 30 be a 330-degree angle. So my other two answers will be multiples of pi over 6, because pi over 6 was my reference. 210 is 7 pi over 6s. 330 is 11 pi over 6s. So there's my other two answers. Okay, the next one, number 22. We have the cotangent of 2 theta times the 2 times the tangent of theta plus 2 equals 0. Again, you see that double angle right here. The cotangent of 2 theta, if you notice your double angles, you have only sine, cosine, and tangent. So what we're going to have to do is we're going to have to use the tangent of 2 theta. However, we know that the cotangent will be the reciprocal of that. So we could actually just flip this side, and that's what the cotangent of 2 theta will equal. So let's go ahead and replace cotangent of 2 theta with that. And now we have times 2 tan theta. Now notice what happens with this problem. Those actually cancel each other out. And then plus 2 is equal to 0. So I now am left with 1 minus tan squared theta plus 2 is equal to 0. Combine all your like terms. These do combine. So I have 3 minus tan squared theta. Now I'm going to go ahead and move my tan squared over here. I'm going to isolate it, and that gives me 3 equals tan squared theta. To get rid of a square, we're going to square root, and that's going to leave me with the tangent of theta is equal to positive and negative root 3. So we're asked, where is tangent equal to positive or negative root 3? We're looking for all solutions between 90 and that'd be 90 and 270. So we're looking for all answers from here to here. So find your reference angle first. Where is tangent equal to root 3? That's going to be at a 60-degree angle. So you're going to have an answer here and here that have a reference of 60. So if this is 60, that's going to be 180 minus 60, which is a 120-degree answer here. This will be 180 plus 60, which is a 240-degree answer there. So my reference angle again was, and we're dealing with a positive and negative, so it wouldn't matter if there's a positive answer or a negative answer, all of them work. So our reference was pi over 3. So we're going to have two different answers who have that reference angle. 120 would be 2 pi over 3s. 240 would be 4 pi over 3s. There's your two solutions. Number 23. Now we're using half angle identities. Like here we have the sine of x over 2. We're going to have to do something with that. We're going to have to replace it with its half angle identity, which is right here. So we're going to take out sine of x over 2 and replace it with this. And there we go. We've taken out that and replaced it. Now we have an issue here. That whole plus and minus is a little confusing. So here's a trick that we can use to get rid of it. It's very similar to the trick we did a while ago. Let's square both sides. Because if you square a plus minus, it's all going to be positive. So when you square the left side, you're going to be left with cosine times itself, which would be cosine squared. Multiply the 2 and double it. So that's going to be plus 4 cosine x. And then square the 2 gives you 4. Equals, when you square the right side, again, the plus minus goes away, the square root goes away, leaves you with 1 minus cosine x all over 2, which looks much better. You can distribute that 2 first, and that's going to be 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine x. Combine all your like terms, and then you have a quadratic trinomial. 2 cosine squared x plus 9 cosine x plus 7 is equal to 0. This is going to be a slip and slide factoring, so I'm going to go ahead and change all my cosines to u's just to make it easier. That'll be u squared plus 9u. Let's slide the 2 to the end, so that'd be plus 14 is equal to 0. Two sets of parentheses, adds, multiplies would be u times itself would be a plus 2 and a plus 7. You slip the 2, so now divide by it. That's going to be u plus 1 and 2u plus 7. So now let's replace that back with our cosine. So that's going to be cosine x plus 1 and 2 cosine x plus 7 is equal to 0. Set them each equal to 0, so you get cosine x is negative 1 and cosine x is negative 7 halves. First off, I know I don't have to worry about cosine of x is negative 7 halves. The range for cosine is negative 1 to positive 1. That's outside the range. However, cosine is negative 1. Again, we're talking about a quadrantal angle there since it's negative 1. Where is my cosine value, which again is my x value on my unit circle? Where's that equal to negative 1? If you draw that unit circle, now let's see, we're looking for answers between 0 and 2 pi, a complete rotation. My cosine is equal to positive 1 here. It's equal to negative 1 here, 0 here, and 0 here. So this is the only answer that we're going to have, and that's going to be pi, or 180 degrees. Number 24. 1/2 tangent of a over 2 minus cosine squared a over 2. So you actually have two different half angles here. And a reminder also, tangent of a over 2, let's go back over here. Tangent of a over 2, there's 3 different formulas we could use for that. Okay, so that I don't have to deal with that plus minus. However, I'm going to, and this is going to be experimental. You might try one and it doesn't work and you have to try a different one. I'm going to replace it with this one, and I'll show you why as we go. 1 minus cosine over sine. So we have 1/2 times 1 minus cosine of a over sine of a. Minus, now here, this is kind of nice. You have squared, the cosine of a over 2 squared. So now the cosine of a over 2, again, is replaced right here. But, well, I'll talk about it as I write it down. Plus and minus the square root. So let me put it in here. Plus and minus the square root of 1 plus the cosine over 2. What is super nice about that is that stuff is being squared. So that's going to help us out tremendously. times cosecant is going to be 1 over sine. I'm going to replace that. And here's why I ended up choosing what I did for tangent. Is look at the bottoms. When I square this and this goes away. And on the bottom, I have a 2 and I have a sine A. So that's the reason I picked the one that had the sine A on bottom over here, because now I have a 2 and a sine A on bottom there as well. So I've already got a common denominator to subtract these two. So on top, I have 1 minus the cosine of A over 2 sine A minus 1 plus the cosine of A over 2 sine A is equal to 1. So I have a common denominator so I can combine the tops. Since you have minus a fraction, remember that this is going to be in parentheses. When you do 1 minus 1, those will cancel. Negative cosine A minus cosine A would be negative 2. Cosine A is what is left on top. On bottom, you are left with 2 sine A is equal to 1. The 2 and the 2's cancel. I'm actually going to take this negative, move it to the other side, and you've got cosine A over sine A, which is actually cotangent of A, is equal to negative 1. Again, we don't like working with cotangent, so instead let's work with tangent. So tangent would be the reciprocal of negative 1, which is also actually negative 1. So now we're looking for all answers from pi to 2 pi. That'd be from 180 to 360. So that would be from here over to here, where tangent is equal to negative 1. All students take calculus. Tangent is positive here and negative here, so we know that we won't have any solutions here. Our reference angle, tangent, is equal to 1 at 45 degrees. So therefore, my answer is going to be here. It's going to have a reference angle of 45. However, tangent will be negative 1 in this quadrant, so that's going to be a 315 degree angle, which will be a multiple of pi over 4. Pi over 4 is the 45. 315 is 7 of those, so my only answer is going to be 7 pi over 4. Okay, number 25. Here we're using product to sum identities. So we have sine of theta minus sine of 3 theta. Now you could, instead of using product to sum with the sine of 3 theta, you could have used other methods here. This is just one way of working this. Like I said, there's several different methods that you can use for solving multiples of these. So just keep in mind, just because this is the way I solve it, that doesn't mean it's the only way to solve it. Now let me show you why it's such a good way, a good method of using it. Notice that we have equals to 0. However, we have a subtraction. Now, if you had two things multiplied that give you 0, then you can set them each equal to 0 and do what we've been doing. So if we could somehow change this difference to a product, then we could use that method. And here's how we're going to do that. We have a difference between two sine values. So we can use this to change that to a product like that. So sine of A minus sine of B is equal to, and I'm going to take all my A's and B's and I'm going to go ahead and plug them in. My A value here is theta, my B value is 3 theta. So I'm going to use this identity. For all my A's, plug in theta. For all my B's, plug in 3 theta. And here's what it's going to look like. So now I have that product that I was looking for. So I have 2 times the cosine. Let's clean it up a little bit. 4 theta over 2 would be 2 theta. Sine of negative 2 theta over 2, which would be negative theta, is equal to 0. Now, anytime you have the sign of a negative, remember that you can use, let's scroll back up, the sign of a negative is right here. We can bring that negative out front. So I could actually just erase that negative and put it out front here. All of these 3 things multiply to give you 0, so let's set them each equal to 0. You can divide by negative 2 on the other side, and that would go to 0 anyway. So we got now either the cosine of 2 theta is equal to 0, or the sine of theta is equal to 0. So we're looking for everywhere between 0 and 180, or 0 to pi. So let me sketch out that from here to here. Everywhere that either cosine of 2 theta is 0 or the sine of theta is equal to 0. Now, since I have the cosine of 2 theta, we can now go back and let me find it again. We can use any of these identities to change that to is something else. I definitely would not use this because it combines sines with cosines, but any of the other ones would be fine. I'm just going to replace it with this, 2 cosine squared minus 1. Oops. So that's going to be 2 cosine squared theta minus 1 is equal to 0, which looks a little bit better now. Move the 1 and 2 over, gives you cosine squared theta is equal to a half. So therefore, cosine of theta would be plus or minus the square root of 1/2. That's going to be the square root of 1 over the square root of 2. Let me go ahead and clean that up. The square root of 1 over the square root of 2. When you rationalize that, multiply top and bottom by root 2, that gives you root 2 over 2. So therefore, there's all your different ones. And when again, we're looking for all answers from 0 to 180. Now, since we're dealing with positive and negative here, we really are not concerned about the quadrants. But I know that at 45-degree angle, that's going to be my reference. That's where cosine is equal to positive root 2 over 2. However, we're going to have another answer here because we want positives and negatives. So pi over 4 is going to be one of my solutions, which is 45 degrees. This would be 135 degrees, which again is going to be a multiple of pi over 4. 135 will actually be 3 pi over 4s. So there's 2 of my answers. Also, I'm looking for where does sine equal to 0. That's a quadrantal angle. A sine value is a y value on my unit circle. My y is equal to 0 here, and my y is equal to 0 here, and that'd be at 0 radians and at pi radians. There's my other 2 answers. And finally, the last one. Same thing, we have a product to sum here, or product sum to products. You can use either one. Here, I have a sum that can be changed into a product. And again, this is going to be, okay, try something, see if it works. If it doesn't work, try something different. So I'm going to take my cosine 2y plus cosine 4y, cosine plus cosine, let me scroll back down, and use this sum to product identity. Let me erase that. Let's apply it. Our A value and our B value will be 2y and 4y. That's A, that's B. Let's plug all that stuff in and let's just see what happens. And there's what we get when we plug it in, and that's equal to the cosine of y. So that's going to be 2 cosine, when you reduce this, this will be 3y. The cosine of negative y is equal to the cosine of positive y. Now, let's see. Cosine of negative y, we don't want to deal with any negative angles, so let's go back to our identity sheet and remind you that cosine is an even function. And what that means is you can actually just dump that negative. You don't have to worry about it, so you can just erase it right there. And I notice now I have 2 terms, one on the left side, one on the right side. However, when I move this term over, both of my terms contain a cosine y that can be factored out. So that's going to be my first step. Move that over. Let's factor that cosine y out of both of these terms, and that's going to clean it up nicely. So you have cosine y times 2 cosine 3y, and then minus 1 is equal to 0. Set each factor equal to 0, and that's, like I said, it's got it cleaned up a good bit. Cosine of y is 0, or 2 cosine of 3y minus 1 is equal to 0. Now I'm going to show you another trick on this one that we could have actually used on the last one. We could have used it right here because we have a double angle. You did not have to use a double angle identity. You could have actually used the method I'm about to show you. So let's start over here. Well, where does cosine equal to 0? That's a quadrantal angle. That's where does my x value on the unit circle equal 0? We only want the answers between pi and 2 pi, or between 180 and 360. But where does my, let me draw that. I like to have that visual. So between 180 and 360, where is my x value? Because cosine is an x. Where's the x value on my unit circle equal to 0? And that'd be right here at 270. 270 is 390. So there's my first answer. Okay, now with the second one, cosine 3y, let's go ahead and move our 1 and 2 over. So I now have the cosine of 3y is 1/2. Now before we had to use the double angle identities and all that. Here I could go in that direction, but there's probably a better way of working this. Okay, let's not worry about the whole 3y stuff yet. Let's simply do the cosine. Where does cosine equal 1/2? Now, we're looking for angles between pi and 2 pi. Now, what I'm going to do is just because I want my final answers, I want my y values but to be between pi and 2 pi. Let's go ahead and list out several answers where cosine is equal to a half, or we could actually list out our infinite answers. Watch this. Cosine is equal to a half. Okay, my reference angle is going to be here at 60 degrees. So if we're trying to find all the answers, so we know the cosine of 60 is 1/2. We're going to have also another angle down here in the fourth quadrant where cosine is also positive. So if this is a 60-degree angle, then we have a 300-degree angle. So therefore, cosine is equal to 1/2 at 60 degrees and at 300 degrees. Those answers repeat every 360. And I'm going to write this. Let's do it in terms of degrees, and then we'll change everything to radians. So my answers are going to be 60 degrees. My angle, now careful, my angle is not y. My angle is 3y. My angle is going to equal 60 degrees plus a rotation. Every 360 degrees, that answer is going to reoccur. So plus n times 360. My answer is also 300 degrees. And that answer is going to reoccur every 360 degrees as well. So what we're going to do to get y by itself here, to figure out what y is equal to, let's divide everything by 3. Mark this out, divide by 3 and divide by 3. And now my answers. My first answer is actually equal to 20 degrees plus, when you divide 360 by 3, it gives you n times 120. My other answer when I divide by 3 is equal to 100 degrees plus, and that answer is also going to occur every 120 degrees. So these answers, let's interpret this now. These answers, 20 degrees is one answer, plus 120 would be 140 is another answer, plus 2 120s, plus 3 120s, plus 4 120s. So I only want the answers, let's scroll back up, between 180 and 360. So all answers between 180 and 360. So 20 does not work. Add a rotation or add a 120. 140 is not in that rotation. Add two 120s to 20 plus 240, which is 260. There's one answer. Add three rotations. That would be 360 plus 20. That's 380. That's not in our domain here. So therefore, that's the only answer there. Now let's move on to the other one. 100 degrees is my first answer. That's not in between here. Let's add 120. So that gives you 220. So there's one answer. Add two 120s. That's 240. 100 and 240. That's 340. So there's another answer. And that will be the only one. You could add another 120. That'd be 460. That's outside of that. So there's all the answers. And you could then just turn right around and change all of those to radian measures, and that's what you're going to have. And I will go ahead and list those for you. My radian measures, let's see, the easy way of doing this, I did multiples of 20. So I know that pi divided by 9 would give me 20. So this would be 11 of those. So that'd be 11 pi over 9 would be one answer. This would be 1320. So that'd be 13 pi over 9. And this would be 1720, so there'd be 17 pi over 9. So there's all of your angles in radian measures now. So 3 pi over 2, those three answers are all of our solutions.